Does this look familiar to you? It should. It's our IPv4 header. Why am I showing you an IPv4 header during an IPv6 discussion? Because I want you to compare here. I want you to compare the two. Because we have a simpler header with IPv6. You might be saying, wow, it's huge. It's way bigger. Well, wait a second. Yeah, it's bigger. But look at the size of our addresses. Look at the size of our addresses. There's way more addressing information here that we're dealing with because we're dealing with 128-bit addresses. So let's go back over here. So we have our source address and our destination address in here and with our IPv4. And we also have that with IPv6. Fair enough. So that hasn't changed at all. We have our version field. Here it says version 4. Over here, it would say version 6. So that hasn't changed. Notice how it says traffic class here. So traffic class is the same as type of service. So if you want to compare the two, traffic class, type of service, we're referring to flat out quality of service values. So differentiated services code point, DSCP values, type of service field, whatever you want to call it today. That is what goes in there. And we have that with IPv6 as well. So that hasn't changed either. But notice something's missing now, right? There's something missing between version and traffic class. We go back here, we had a header length. So we're not going to keep track of the header length in this particular case. There's no need to for IPv6. Why? Because our header length is variable. Our header length is variable. By default, the header length is going to be a very specific size of 40 octets. 40 octets in total. That is going to be the size. But after that, the header can be variable based on the different features and services that we want to add into the overall communication process. But the basic header is 40 octets. It'll always be 40 octets. And it's made up starting with the version here, going all the way down to the address. There's our 40 octets. After that, it becomes variable based on what we've implemented. So we don't need that header length field anymore. We have a flow control field in there. That's just and that's an extra field. That wasn't available in our IPv4 deployment at all. But the flow label here allows us to, almost like quality of service, manipulate the traffic and discriminate certain traffic versus other traffic. For example, voice versus video. But here with the flow label, we have the ability to do it on a flow-by-flow basis. So this is just a little added extra feature that we have available to us for some traffic manipulation as well, if we need to. Identification, flags, and fragment offset, all gone. All gone. Why? Because in the past with IPv4, we allowed our routers to do fragmentation. We allowed our routers to take a packet that was too big and break it up into smaller packets, so that way there it could be forwarded out of an interface that wasn't, let's say, using the default MTU as 1500. So when that got broken up, the identification, flags, and fragment offset had to be adjusted, and the information had to be inputted in there, so that way there the packets could be reassembled in the proper order at the other end, and then everything being put back together into the overall segment when it's all said and done. We don't do that anymore with IPv6. You see, with IPv6, routers are never going to perform fragmentation. That's right. If the packet's too big, the packet gets dropped. It's as simple as that. So who's responsible for fragmentation? The original source device.